Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on similar triangles. So just as for congruence, triangles represent a special case in similarity. In a previous video, I told you that two figures were similar if all their sides were in proportion and all their angles were equal. But it turns out for triangles, we don't need to check every pair of sides and every pair of angles. Instead, to determine whether or not two triangles are similar, we can use one of these four tests. So let's get started. We'll look at these black triangles over here. So in these triangles, it turns out that all sides are in proportion. So how do I know that? Well, the largest side divided by the largest side in each case. 12 over 6 is 2, 10 over 5 is 2, and also 8 over 4 is 2. All sides are in proportion and have a scale factor of 2. So just for triangles, it turns out that if all sides are in proportion, then all angles will be equal to. That is called the SSS or PPP test. Of course, it means the sides are not equal, but they're in proportion. So this is different than what I told you in a previous video for quadrilaterals, for example. It's possible that you have two quadrilaterals where all of their sides are in proportion, but they don't have the same set of angles. That's not the case, however, for triangles. You can't have two triangles where all sides are in proportion and the angles are not equal. So all sides being in proportion for a triangle is enough to show similarity. It does actually mean that all of these pairs of angles will be equal. So this angle and this angle will be equal. It means this angle and this angle will be equal, and these two angles will also be equal. So that's the first test. All sides in proportion, SSS or PPP, doesn't matter which one you use. So now let's go ahead to the second set of triangles, the green triangles over here. So you can't ever just have one pair of sides in proportion. That doesn't make sense. You need to be able to compare it to something. So here we have two pairs of sides that are in proportion. Now don't get confused because a rotation has taken place here. The 6 corresponds to the 9. Shorter side corresponding to shorter side, and we also line up the longer sides in each triangle. So 12 over 8 does equal 9 over 6. Both are equal to 1.5. So we have two pairs of sides in the same proportion. We also have the angle between them being equal. So this test is called SAS or PAP. It doesn't matter which one you call it. Once again, the P or the S means sides in proportion. Now, this is analogous to the SAS test for congruence. So remember in that, the A had to be the angle between the two sides, and it's the same here. For the SAS or PAP test, the angle you're given must be between the two sides that are in proportion. If I gave you another angle like this one here and told you they were equal, that wouldn't be enough. It must be the angle between. It has to be those angles circled in red. So this means if two triangles have two pairs of sides in proportion and the angle between them is equal, then they must be similar. We don't need to check the other sides and angles. So just note here, when we use S or P, we're talking about a side in proportion. But when in these tests we call A, we're actually talking about angles being equal. Alright, let's now go to these triangles down here. So again, we have a couple of sides in proportion. You need at least two pairs of sides in proportion. You can't have just one side in proportion. So these are in proportion because 3 over 2, the two hypotenuses are in the same proportion as the shorter sides here, 1.5 over 1. Both of them equal to 1.5. Also have a right angle here. So even though that's not the angle between them, we can get away with it in this case. So this test is called RHS or RHP. It's analogous to the RHS S test for congruence. So when you have a right angle, things are a little bit different because we can use Pythagoras' theorem. So even though this is two sides and not the angle between them, these two triangles will be similar. If you have the hypotenuse and another side in the same proportion, as well as a right angle in both triangles, then the two triangles will be similar, okay? If you don't have a right angle, remember it must be the angle between the two sides, but it's a different case when we have a right angle. So let's look at the last pair of triangles. It turns out that they are similar as well. So, why are they similar? Well, they both have a right angle, and they both have this common angle. So they will have two pairs of equal angles. Now, if two triangles have two pairs of equal angles, they must have three because of the rule of 180. So I know that this angle here is equal in both triangles. These angles are equal, so then this and this angle must be equal because of the rule of 180. So this is called the AAA test, or if you like, the AA test. If two triangles have all angles equal, then their sides will be in proportion. I don't need to check. And if two triangles have two pairs of equal angles, they must have three pairs of equal angles for the rule of 180. So this is sort of a totally new test. There isn't an analogous test for congruence. So if two triangles are similar, we write a similarity statement. So I'm only going to write the statement for this last triangle here. So remember, we can call the first triangle whatever we want. So I'll call the smaller triangle SVW, and we use this symbol for similarity, like parallel with an extra line, or you can use this one. Either one doesn't matter. So the second one, we need again to line up the vertices. So in the larger triangle, S corresponds to itself, V corresponds to T, and W to U. That's how we write a similarity statement. All right, what we're going to do is just a few quick proofs where we're going to formally prove that two triangles are similar. So please pause and copy this down if you need. Okay, so we're going to look at each of these diagrams and formally prove that the triangles are similar to each other. So when we're formally proving, we need to say why things are in proportion or equal. So let's start over here. So I have two pairs of sides. Hopefully they're in the same proportion, but I also have the angle between them because I know that this angle and this angle will be equal because they're vertically opposite. So let's check that the sides are in proportion. So it might be a bit tricky for you to think, okay, which side lines up with which? Well, as I was saying before, what you do is you line up the sides that are largest in each triangle and the sides that are smallest. So line up largest side with largest side. So the largest side in each triangle, I get 10/8. And then I line up the smallest sides in each triangle, so 9 and 7.2. So if I put 10/8 on my calculator, I get 1.25. If I put 9/7.2 on my calculator, I get 1.25. So this is enough to show that I have two pairs of sides in proportion. So that gives us two S's or two P's. And then I just need to say what I said before, that angle ACB is equal to angle ECD, and the reason is they're vertically opposite. So now I've shown that there are two pairs of sides in proportion, the angle between them is equal, so I write my similarity statement. Therefore, triangle, I'll call the first one ABC, is similar to this symbol or this symbol, triangle. Now, A will correspond to E, B corresponds to D, and C corresponds to itself, and the test I used was PAP or SAS. So that means X, of course, corresponds to the 50-degree angle, so therefore X equals 50 degrees. Because these two triangles being similar means they have the same set of angles, corresponding angles must be equal. All right, let's look at this one now, the red triangles. So here, I don't have enough information to use sides in proportion. Remember I said before you have to have at least 2 pairs of sides in proportion. I don't have the lengths of 2 pairs of sides. There's not enough information to use any of the tests involving sides in proportion. When you don't have enough information about side lengths, your only choice is to use a test, and that's exactly what I'm going to use here. So I need to show there are 3 pairs of equal angles. So starting off, this angle here is in both triangles, so it must be equal. So I can just write angle BAC is common. It's in both triangles. Now, because of the parallel lines here, I should straight away be thinking alternate or corresponding angles. So I know this angle and this angle are equal because they are corresponding. Remember, we did a tutorial about that a few lessons ago. So I write that formally. Angle ADE, which is this one here, is equal to that one there, which is angle ABC. And the reason is they're corresponding. So remember what I said before, if you've shown that there are 2 pairs of equal angles, the third pair must also be equal because of the rule of 180. So I can write this angle and this angle must be equal. So the first one, the top one's AED, equals angle ACB. So the reason for that, they are also corresponding, but they're also going to be equal because the other 2 angles are equal. So I can write rule of 180 or corresponding. So therefore, triangle ADE, which is the top one, is similar to triangle. So in the big one, A corresponds to itself, D corresponds to B, and E corresponds to C. The reason was the AAA test. So now let's find what X is. So the scale factor, we need to find some corresponding sides. So this side here is 12.6. So the scale factor is actually 12.6 over 7, or 1.8. So don't be fooled here of thinking it's 7 over 5.6. It's not, because 5.6 is this length here. It's not actually the length in a triangle. You need to actually have the length here that's in a triangle. So, of course, if the scale factor is 1.8, then X, because it's in the larger triangle, will just be smaller times scale factor, which is 7.2, and just write U for units. Alright, that's it. Thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.